Tim, take a look at the Lincoln Electric 0.035-inch FluxCore welding wire. I do like to put it in the bag to help keep moisture and stuff out. So that's nice. So you can see it, this is Innershield NR211MP and it is 0.035 inches. So you got a double bag. So that's nice. It's always nice having this wire being fully protected when I get it. And it is also labeled on the roll so you can tell exactly what it is. This is a 10-pound roll, and as a reference, this is the exact same stuff. And that is a 1-pound roll. Now, if you know you're going to be doing a lot of welding, this is the obvious choice. Even just the wire it takes to feed up to the gun every time you have to put in a new roll like this. This is just going to save you a lot of wire in the long run, and on top of that, it's just going to last a lot longer. If you just want to try FluxCore wire, then this is a nice little package to get. So you can try this out, see if you like it, and then go from there. Now, I like FluxCore wire because you can use this thing in the wind. You don't have to worry about argon gas. You do still have to deal with the slag afterwards, and there is more spatter than you would get with normal gas MIG welding. The fact that you don't have to carry a tank around with your welder makes this stuff a lot more versatile, in my opinion. I think for a shop scenario, having a tank is probably the best just because not having to deal with the slag afterwards means that you can be more efficient, more effective, quicker. But for anything outside or DIY, this is the best type of wire you can get. And that is important to note. Because this is 0.035, you have to make sure that your welder is compatible with that. Usually there's a little wheel on the inside of the welder you can flip back and forth to get the different size of wires. Just because it doesn't feed properly, you get a lot of on and off sparking and that kind of thing. So you want to make sure you have the correct wire for your welder. This is 0.035, which is the correct wire for my welder. So this is going to be what I'm going to be using. When it comes to wire, you want to get good wire. This Lincoln Electric wire is among the best. So I got my K groove. This is a 0.035 and I've got that facing out so that this groove will line up with my channel. And I'll just drop this in. There is that little lip on there that's going to sit against it. So I'll put that on properly. And the reason that we're doing this is because we want there to be a little bit of tension on this roll. There we go. Now this is the part that can mess up people if they've never done it before. So I'm going to take the wire. We don't want to let it go, because if we let it go, it will unspring and then it'll be a problem. So we want to get that out to a point where we can start feeding it through here, but we also don't want to have all these bends in this wire. I'm going to cut all that nasty stuff off. I'm going to bring it back, feed it into there. I'm going to get it to the point. And of course, you know, it should probably go without saying, but just to say it anyway, we do not want to have the welder on while we're doing this. Now, worst case scenario is I mess up and I bend this thing a little bit. If that happens, that's okay. We just take it out, cut off a better piece, and get started again. Because what we don't want to have happen is we don't want this wire poking anything on the inside of the of this cable. There we go. So we are started. I'm going to drop this down and put a little pinch on it. Now with FluxCore, the amount of tension that you put on here can make a big difference, because if you put too much on, most people, they just want to crank on it. If you put too much on, you'll also have feeding problems. So you just want to get a little bit on there just so those wheels can grab it. But you want it to be loose enough so that when you pull that trigger, if you put your finger on the wire, you can actually stop it. So it needs to be tight enough to be able to drive it, but still loose. That is what it should look like when it's done. So we got the wire in the groove and then going out that tube. And we don't want anything that can possibly get in the way here. So I'm going to take off the nozzle and I'm going to take off the tips. So just to get the wire fed through, I'm going to take everything off, and that way I don't have any obstructions to get in the way. Now I want to have the door open so I can make sure that there's nothing getting kinked inside of here. I'm going to turn the power on. So I want to get the length that I'm going into as straight as I possibly can, and then I'm going to hit the cold feed. All right, looks good. So as it's moving, it's not binding or twisting or anything like that, so I know we're good. So now I'm going to pull this straight all the way, and I'm just going to keep on pressing the trigger. And there we go. Now we can reattach the tip. So that 0.035 is a very nice fit on that wire. You don't need to crank this, you just want to make it a little tight. And put the nozzle back on. And then we'll cut off the extra wire. So we're already on MIG, wire speed. I'm going to be going, I think it's a little bit under an 1/8 inch steel. So it said 6, so I'm going to go with, we'll just say, yeah, let's go with 6. And it says 16.5 for the volts. So let's go with that. Okay. So two things. That was very smooth, so I love the way that that was actually running, but it was way too hot for this little piece of metal. So it burned a hole right through it, and that is the back side of it. So I gotta turn that way down. So we had it set for 1/8 inch. Let's go ahead and bring that down to a 3/32. It recommends 4 and 15.2. Okay, let's see how that goes. Okay. So maybe a little thin. I think I might have gone a little bit too fast, but this guy, look at that penetration. I am very happy with that. And probably what's most important to me, like when I was listening to that welder, it was coming out beautifully consistently. That's the most important thing, because without a consistent feed, I can't weld. But I mean, ultimately, that weld that I just put down, that would definitely hold something together.